All right, let's try this. So again, here, let me show you the. So there's the formula again. A equals P. So everybody got that copy down? So A equals P, parenthesis, 1 plus R over N to the NT. We're going to just keep using that formula a bunch. We'll have one other formula also. And then there's what everything means. So A is the amount, P is the principal, R is the interest rate, N is the number of compoundings. That's important. Monthly is 12, semi-annually is 2, quarterly is N equals 4, daily N equals 365. That's our problem. N and T is the number of years. Okay, so with that in mind, so we'll use A equals P, 1 plus R over N to the NT. So let's see if you can plug everything in on that one. And hit the buttons on your calculator. Give you a second on that one. Feel free to compare with those around you. All right, we good. Principal's 200, right? That's principal. The interest rate is 0.03 divided by N. N is 365, right? Daily, compounding daily, 365 days in a year, unless it's leap year. We just use 365. N is 365 times T. T's number of years, 4 years. So you got to figure this out first before, do that first. I would take 365 times 4. What is that? 1460? So then type that into your calculator. So what's that? 200 parenthesis 1 plus 0.03 divided by 365 to the power 1460. I'm getting 225.498. So that rounds actually to 50, huh? 225.50? That coming out okay? Questions? Is that good? All right. They have a new word now, compounded continuously. So when they say continuous, for continuous compounding, you use a new formula. A equals P e to the RT. We use R. That's where R comes from. It has to do with continuous compounding. That's one of its real life applications. That's where they first discovered it, I believe. I believe that's where they first came up with it, was within continuous compounding real life money problems. So continuous compounding. So in other words, they're not compounding the money every month or twice a year or every quarter or every day even. It's continuously growing, continuously compounded interest. In that case, you use this formula. Use the E instead of the other formula when they say continuous. All right. The rest is the same, though. So $40, that's the P, huh? And we use E. The R is the 12%, 0.12. And the 4 years. Every problem's been 4 years, hasn't it? 4 years. Want to hit the buttons? And again, I would figure out the power. Y'all notice how I'm doing the power thing first, 0.48. It's because, just do the power first. So I'm trying to save time and also be clear. Because if you have more than one thing in the power, you'd have to put parentheses around it all, or it would just do the first thing. Just figure out the power first. It'll be easier to do on your calculator. So on the calculator, I'd go 40 times. The E button is usually second natural log, e to the x. It's usually second ln on most calculators. E to the power 0.48 equals. So 40 times e to the power 0.48 equals. I'm getting 64. Y'all getting that? Is that okay? If you have any trouble, grab me after. Questions? So on number 6, first off, which of the two formulas am I gonna use on this one? Is this continuous compounding or some other kind of compounding? Monthly. So it's not the PERT. The PERT is only for continuous compounding. So it's the A is P 1 plus R over N to the NT. It's that one because it's monthly, not continuous. Good. Just use the PERT formula for continuous. Okay. Now let's go through it. Notice it says to get 300. So that's the A, isn't it? That's the amount you want later. Remember when back here when I first gave you the formula, the A is the amount at the end. The P is the principal at the start. The money you first put in the bank is the principal. What you get at the end is the amount, is the A. So therefore, they're telling me we want to get 300. We want the answer to be 300. What's the principal? That's what they're doing a reverse question on this one. They're saying find the present value. Another way of saying principal. What's the value today that will grow to become 300 later? That's what they're saying. And what's the interest rate? 11%. A monthly. What's in equal for monthly? 12. Monthly is 12 months in a year. And the time is 3 years. So I would just right away make that 36. I always do the power first. Just find out 3 times 12, 36. Good to there. So let me bring it over here. So we have 300 equals P 1 plus 0.11 over 12 to the 36. Good to there. I'm trying to solve that equation for P. They want to know the present value. Like how much money today will become 300 at 11% after 3 years. So how do I solve for P? What present amount today will grow to become the 300? If you're like saving money, think I need $300 to buy whatever in 3 years. So how much do I need to put in the bank today that'll grow to become $300 in 3 years at 11% compounded monthly? So how do we solve this equation for P?
You just divide.
Divide by that big old chunk, huh? Just divide by that whole thing. Boom, boom. Whatever you do to one side, no choice. But the same thing to the other. There it is. So P will equal that. So how do you enter that in your calculator? Let me give you some help on this one. You could enter it all straight, but it's a little messy. What's easier? You guys have the A and S button on your calculator, the answer key, at the bottom of your calculator, A and S. That's really convenient. So what I would do is I would just start with the bottom. I would just go 1 plus, oh, you need parentheses. Parentheses 1 plus, whoops, doing 2 decimal points. 1 plus 0.11 divided by 12 to the power 36 equal. So that's the denominator. Because the denominator is the big messy part. So get that first, and then go 300 divided by answer. Hit the answer button, equal. Just real easy way. You don't have to worry about extra set of parentheses for the denominator and all that. Just real pretty quick, convenient way. Just do the harder part first, the denominator. I'll do it too. 0.11 divided by 12 to the power 36. So for the denominator, I got 1.3888, whatever. But I'm not going to write it down. Don't need to do anything with it. That's the denominator. Now I just simply type 300 divided by answer. And the final answer, I got 216.00. 216.001. So just say it, $216. Need to put $216 in the bank. It'll grow to be $300 in 3 years at 11% compounded monthly. Is that good? You good with using the answer key and all that? Real convenient on the calculators now. Questions? We good? Okay, you want to try that one? So I'm keying in on the words continuously, compounded continuously. So what does that mean? We use the PERT formula, huh? We use that other formula. So if the compounding is continuous, we use the PERT formula. If it's not, then we use the A equals P, 1 plus R over N to the NT formula. Continue, so use the PERT. See if you can solve for that one. Give you a second. How we doing? You guys doing okay? The 90, what is the 90? That's the amount, huh? That's the amount we want later. We're looking for the P. And the R is the 0.05. And the T is 3.5, 3.5 years, right? Just put in 3.5 like that. Is that good? And then again, I would figure out that power. 0.05 times 3.5. That's how, so this comes out to be 0.175. Those two, so bring it up here. So I've got 90 is P e to the 0.175. I just always figure out the power ahead of time. Good to there? Is that good? And then how do we solve for P? Just divide by that e to the 0.175. Boom. So then 90 divided by e to the power. I'm getting 75.55. Is that okay?
Wouldn't it be 1.75? Because it's 3.5.
3.5, but it's times 0.05? Did you have 0.05 or accidentally do 0.5? Yeah, the 5%, make sure you make that 0.05 on that.
3.5, got it.
Two places, right? Percentage always go back two places, so there's two zeros in the symbol. It's a very helpful symbol, right? It's got two zeros in it. It's reminding you, two places. We good on that one? Is that okay? All right, you guys are never a very talkative group, but please give me feedback. Let me know. Yeah, effective rate. These are a little tricky. Yeah, so when they say effective rate, I'm going to do a different thing than Math Excel here just because they do a kind of a difficult thing. So, I mean, click on the Show Me an Example button. They do kind of a weird thing. So, effective rate. Effective rate means what is the real effect of that kind of investment scheme. So, for example, if you take 10% and you compound it one time per year, well, then that's just 10%. Your money will grow by exactly 10%. But if you take 10% and you compound 2 times per year, the effect of that, I don't know, what will be the effect of that? How would I do that? It's 0.05 to the, yeah, the effect would be 10.25% growth. And if you take 10% and you compound it, I don't know, let's say daily, like every day. So let's see if I can do that. And I'll show you how I'm doing this in a minute, but let me just give you the idea first off. 0.10 divided by 2.5. Yeah, so I'm getting 11 goes over it. Oh, no, 10. 10.55 5.2 actually, 5.2%. Anyway, so my point, growth. So my point is, interest rates are different effect depending on how you actually compound them. If you compound money more frequently, it grows more rapidly. So for example, 10%, if you only do it, when we say, when a bank or a loan says, hey, blah, 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 this loan is 10% compounded once per year. There's actually laws now, truth in lending laws, that say they have to tell you the actual effect of the loan. I don't know if you ever bought a house or bought a car and you see the whatever, they don't call it effective rate. Sometimes they do. They use some other word like that. But basically, it's what we're going to calculate here. It's the real effect. What's really going to happen? Because there's the listed rate, but then that if they just compound it once a year, then that's that. There's no change at all. But if they compound more than once a year, it grows slightly. I mean, it's not dramatic. But if you do it twice a year, it goes from 10 to 10.25. If you do it every day, it goes from 10 to 10.52. That's a fair bit, half a percentage more. Anyway, the more frequently you compound, it creeps up a little bit. I could show you the math behind why. If you're interested, come to office hours. But I don't have time. I usually kind of do that, but I just don't have time. So let me just show you how we actually crank this out. What we do is we want to find the actual effect of the money. So what I'm going to use, this one's compounded quarterly, so you know which formula I'm going to use. 1 plus r over n to the nt. Good so far? Is there a strange smell in here?
Yeah.
Like gas.
It does smell like gas, huh? Yeah. Little slightly concerning, huh?
Is there a science room around here? Yeah.
Oh yeah, this is the science building.
Oh.
Yeah.
It is.
They're above us.
They're upstairs.
Yeah. We'll see. If it gets stronger, maybe we'll leave. We'll see. All right. We all start passing out, that's a problem. All right. So, okay, so we're going to use this formula because they say compounded quarterly, not continuously, right? Quarterly, okay. Now, how do you do this? For effective rate, because you're trying to find what's the real effect of the money. So you put in, here's my little method, put in $1 for 1 year. Put in $1 for 1 year. Take the answer, subtract out your original $1. Subtract out your original $1. Change to percent. There's the steps. $1, 1 year, take your answer, subtract out the original dollars, and change to percent. In other words, if we're trying to find out what's the real effect of some kind of investment thing, like in this case, 5.25% compounded quarterly. Well, it's going to be a little higher than 5.25 is 5.25, isn't it? It's going to end up being a little better than that. The more frequently you compound, the more it grows. So, if you just do once a year, like I said, one time per year, it'll stay the same. But if you do more than once per year, it'll grow a little bit. So 5.25 done quarterly will come out a little higher, like 5.28 or 5.3 or 3.1, I don't know, we'll see. Something a little higher, we're expecting something a little higher. And so how do you know? Well, just find out what happens to $1. That's my method. Just say, look, take $1, find out what happens to that $1. If you find out what happens to $1, you can find out what happens to every dollar. You can find the effect. That's my plan on this method. Math Excel does some really crazy method. Years ago, I had my son took this class from me just at home, and I just gave him the book, and I never really taught him or anything. I just kind of gave him the book and said, the program in the book, and said, figure it out. When I come home, have it done, I'll check you. My son was quick at math, and so he didn't need any help. So he just did it all on his own. But in this section, he would just always read the show me examples and just follow their lead. In this section, I gave him the test on this stuff, and he did their crazy method, and he messed it up because they have a crazy method. I remember going, Daniel, what happened here? What did you do when I graded his test? What did you do on this effective rate problem? What are all these formulas everywhere? And he's like, well, Dad, that's what the book said to do. I'm like, what? And I looked up the book. I couldn't believe how wacko their method was. I'm like, no, just put in $1 for 1 year, and that's the effect. So that's what we're going to do. So take $1, so the principal is $1. Let's put in $1. and put it in for 1 year. The interest rate is point. Are we all coughing and dying? Are we okay? All right. Put it. Is it getting worse?
It's reminding me of like the bumper car track at Blackbeard.
Yeah, the memories, because the smells bring memories, huh?
It's like motor
What's that?
oil and gas. Exhaust.
All right. So put in the. Are you okay? Is everybody okay? 10 more minutes. Can we hang in there? And I don't hear any fire alarms or anything. So, that's right. Everybody rest building's passed out. We're the last ones. Okay. So move the decimal back 2 places. Over in, what's the number of compoundings? Quarterly is 4. In and T, 1 year. Let's hold on. Am I losing you? So remember what I said to do. Put in $1 for P, and 1 year for T. Remember, to find effective rate, you find out the effect on $1 for 1 year. Get the idea? Get the logic there?
Mm-hmm.
That's how I attacked this problem. I just thought, look, just find out what happens to $1 in 1 year, and you know the effect, right? $1 1 year. I don't know why Math Excel doesn't do it this way, but it's $1 1 year. Whatever happens, happens. So $1 1 year. So I put in the time is 1 year. I put in the principal.
Mr. Harry, did you smell anything?
Yeah.
No. Yeah. What's up?
I called the maintenance and they are going to come over. We all smell that in this floor.
Right.
So they are coming over. So you can do whatever you want, but we evacuate.
Okay.
I don't want anybody to pass out, you know.
Oh, but if they pass out and learn more math, maybe that'd be a good trade. What do you think? No. Okay. All right.
So mean.
Yeah.